Precalc chapter 7 section 4. So we're going to look at kind of the same thing we were doing with Gaussian elimination. We're just going to put it within a matrix form, so performing row operations. So we're still going to use REF, but now we have something called RREF as well at the end of the day, which is called Gauss-Jordan elimination. So a matrix, M by N matrix. So kind of some review of Algebra 2. We have our different rows. So rows are like left to right, and then columns are up and down. So like a column of a house would be vertical. And so we classify it by how many M by N. So how many rows by column. So rows by column. M rows, N columns. And notice how the abbreviation your textbook will use here is A11 means entry row 1, column 1. Where down here, this is row 2, column 1. And so some of these numbers help you know where we're at. So if there's the same amount as rows as there are columns, then the matrix is called a square matrix. And we'll write a lot of those. And we can take a system here. So this system here, we can write a coefficient matrix, which is a square matrix. And so to do that, we look at the coefficients of our variables. We have a 1x, 1y, 1z, 2x, negative 1y, 3z, negative 1x, 2y, and then negative 1z. So those numbers would create our coefficient matrix. And so I'm writing each of the coefficients as rows, each of the equations as a row. And when you look at that, each of the columns are going to be the variables. So this first column is the x column, then a y column, and a z column, the coefficients for those variables. And each row is an equation. So this is a coefficient matrix. An augmented matrix, so this might be a little new here, is the same thing. We're taking these coefficient matrix, but it's not going to be a square matrix now. Now we're going to actually add in our constants or our solutions for these equations. And with the 3 dots, we're going to put the 2, the negative 1, and then the 4. And so this is the augmented matrix. And so pretty much it allows us to write a system of equations in a matrix form, so you don't have all the variables, the x, y, z, and have to keep writing those over and over again. So the Gaussian elimination, same thing we did on the previous section, except instead of leaving it in a system format, we're just going to put it in a matrix format. So remember, you can interchange the rows, you can multiply rows by constants, you can add or subtract the rows. So we're going to have 1, 3, 4, dot, 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 7, 2, 7, 5, 10, and 3, 10, 4, 27. So here is our first step. So there's our augmented matrix. Now we can discuss what we're going to do here. We're going to use our notation. So we're going to do 2 times row 1 and then minus row 2. And then we can also, at the same time, do 3 times row 1 minus row 3. And so I used some of this abbreviation with equation 1, equation 2 in the previous section. We're just going to do the same thing just with rows. And so our new matrix, our first row stays the same. Our second one, we're multiplying the first one by 2. So this is going to become 2, 6, 8, and 14. And then we're going to subtract the second row from that. So 2 minus 2 would be 0. So I'm going to hold that term, that entry, by putting a 0. 6 minus 7, so negative 1. 8 minus 5, so 3. And then 14 minus 10, 4. Then we do the same thing with the third equation. And if you need to do that side work, feel free to do that. I'm just going to kind of squeeze in by multiplying by 3. So I have 9 here, 12 here, and 21. And then subtracting this third column. So 3 minus 3 is 0 again. 9 minus 10, negative 1. 12 minus 4 is 8. And then 21 minus 27 is negative 6. And so we're on that same pathway of trying to get a 0x here or 0x here. Then we want the 0y term. So the next step would just be to subtract. And so I'm going to take row 2 and subtract row 3. If I do that, the first equation, 1, 3, 4, 7. Now the second equation, I can divide everything by a negative, basically just change the sign of it. So I get that leading coefficient of 1. And then when I subtract, a negative 1 minus negative 1 is 0. So be careful with your mental math here. 3 minus 8 is negative 5. And then 4 minus a negative 6. So we're at 10. The last step would be just to write that last equation with a coefficient of 1. And so we're in our final row echelon form of the system is going to be divided by negative 5, so we have 1 here and then negative 2. So this is REF form we talked about. And so we then know this equation here tells me that z is negative 2. I can back substitute that in the second equation, which right now has 0x 1y minus 3 times z equals negative 4. And so I'm plugged in the negative 2. So this is a positive 6. I'm going to subtract that. So y is negative 10. And I can plug negative 10 and negative 2 in for the y and the z term here. So we have x plus 3 times our negative 10 will be negative 30. Plus 4 times negative 2 is negative 8 equals 7. So this is negative 38. Add it to both sides to find x is 45. And so our solution is the order triple, negative 2, negative 10, 45. And so this is using Gaussian elimination within a matrix setup. We can do the same thing with a non-square matrix, and so you go through the same pattern. For this one, I would immediately just switch the first row, the second row, so this becomes row 1. Then I'm going to take this one, multiply it by 4, so it'll be 4, negative 8, 12, and negative 16. Add to the first equation, the original first equation, to find a new second equation. I get 0 here, so I'm adding, so I have negative 7, adding 12, and then adding negative 10. And then we're done with this because we just divide by the negative 7 here because we don't have that third equation. So 1, negative 2, 3, negative 4, and 0, 1, dividing by negative 7. So we have negative 12 sevenths and then 10 sevenths. Now the third equation is going to be 0, 0, 1. We don't have a third equation, so we're going to let it equal a. That's where we're assigning that z value to be a. And then we can back substitute that. So we know z is a, so then y is going to be 12 sevenths, and I'm adding it to both sides, y is positive, a plus 10 sevenths. And I need to plug both of those back into the first equation to find our x value. So you get 3 sevenths a minus 1 and 1 seventh for x, and that's again plugging in. We got to plug in this y value in here for the y, and plugging a in for the z, and that's in this equation. If you put this back in equation format, so you have like the 1x minus 2y plus 3z equals negative 4. Plug in what we know for z and y, then solve for x. Some good fraction work there. You might want to go through and make sure you can do. 57. So putting this in, we have our 0y here. So our 1, 1, negative 5, 3, 1, 0, negative 2, 1, 2, negative 1, negative 1, 0. And so it's kind of so nice. We can just subtract the first two. So I'm going to leave the first one as is, 1, 1, negative 5, 3. And then I'm going to do row 1 minus row 2 to find my new second equation. So I get 0. 1 minus 0 will be 1. Negative 5 minus negative 2, so we have negative 3. And then 3 minus 1 is 2. And then I can also do 2 times row 1 minus row 3. And I could multiply the second one by second equation by 2 and subtract and find a new third one as well. It would not matter. So I do 2 minus 2 would be 0. And then 2 minus a negative 1 would be 3. Negative 5 minus negative 1, so we have negative 4, and then 3 minus 0, so we have 3. Next step is to get rid of this y coefficient. So I'm going to do 2 times row 2 minus row 3. First row stays the same. I still want the second row as is, but I use a multiple of that to subtract to find a new row 3. So then 3 times 3 would be 0. Negative 6 minus negative 4 would be negative 2. And then 4 minus 3 is 1. The last step is to write it with a coefficient of 1. And do you really have to do this? No, you can go through the solving, and a lot of you can see that and know it, and then back substitute it. But we can divide by the negative 2 to get that, and then the negative 1/2 here to show you that the z is, so our solution z is negative 1/2. That's what that last equation is stating. So I can plug it in the second equation here. So that's the second equation would be the y minus 3 times negative 1/2 equals 2. So then I'm going to subtract that to both sides, that 3/2. So y equals 2 minus 3/2, which is 1/2 still. And then I'm going to plug both of those in for my y and z in my first equation. So x plus my y minus 5 times my z equals 3. So this is plus 1/2 plus, because a minus 5 and a negative 1/2 is a positive multiply there. So then we get 5/2. So that's really 6/2 or 3, so I'm subtracting 3 to both sides, so x is 0. So our solution is 0, 1/2, negative 1/2. And that'd be the final order triple. So I just want to talk about our REF now. Reduced row echelon form is when you get the zeros up here as well. And you keep going through the same method of adding, subtracting equations, multiplying to get them. And typically I don't do that algebraically. We can use calculators or programming to do that for us quickly. But the power of this, it tells us that this equation tells us that the z is 8, this one tells us the y is 2, and this one tells us the x is 4. So it tells us the solutions for our 3 variables when it's in reduced row echelon form. So it's pretty powerful to have it in this form. But if I'm doing it algebraically, a lot of times I'll keep it in just row echelon form and then just back substitute to save me all the algebraic work of getting these zeros. And that's the only difference, is the zeros on this side of the ones is what makes it the reduced row echelon form. This one's in reduced row echelon form even though it doesn't have these zeros, and the reason why is because we have the zeros down here where the z equals a. So you need to back substitute to find your solutions for that one because it's an infinite solutions. So here's another example if you want to try taking this system. I'm just going to show you kind of like a generic work real fast. So if you want to practice some more, you can do it with this and have some answers to check your work. The first thing to do is to change it into augmented form. So here's what the answer would be for augmented form. And so if you want to pause and try from here, you can, but here's the solution. So the next step would be here. So this is where you get the x coefficients 0 and 0. And then the next one here would be the 0y. That's the next step they got. And the leading coefficients of 1. So this is REF. So we know that our z is 2. And we can back substitute to find the solution. So here's another one. We take it and put it into augmented form. And then we can actually find the 0x's. Then the 0y's. Notice how we get this statement right here, which you should have an idea what that means. No solution. Because it says that z equals, or 0 equals 1, which is not true. A false statement, no solution. So we're going to stop it there. That is 7-4. See you tomorrow.